Alright, day 5, for loops, range, and code blocks.
All right, guys, well done for sticking it through. You are now on day 5 of 100 Days of Code. And today I've got a fun project for you. And the inspiration for the project comes from the fact that all sorts of companies seem to be getting hacked these days. Everything from Ashley Madison to Verizon, everybody seems to be really bad at keeping your password safe. So, how can we make sure that these hackers who are in hoodies and wearing face masks don't get to you and your account? I also don't know why hackers are always portrayed like this. I mean, they're in their own house, they don't have to hide their face. But at least they're conscious of not spreading germs and staying warm, so that's good. But how do these hackers get into your account, anyways? Well, one of the most common reasons is password reuse, using the same password on 20 different sites from Google to Facebook to Skype to Spotify to all the random services that we sign up to. The problem is that when one of these sites get hacked, then the email and password combination you used to sign up is compromised. So all a hacker has to do is try out those credentials on a bunch of other websites and see if they work. So, how would you know if your email and password is on a database somewhere? You can head over to haveibeenpwned.com, notice the spelling there, and type in your email to see if it was involved in a website that had been hacked. So let's try an email here, elon@tesla.com. And it tells us, oh no, it seems like this email has been pawned. And these were the websites which got hacked, potentially leaking this email and its associated password. I actually recommend you to try out your own email addresses right now and see which services you signed up to have been compromised. But if you want better security, then you'll actually need unique passwords for each and every website. And they should really be strong passwords, not 123456 or QWERTY. If I just called out your password, please change it. Now, what we're going to be building is exactly that. We're going to be building a password generator, something that's going to generate strong passwords with letters and symbols and numbers. First, it asks us how many letters would you like in your password? I would like 12. How many symbols would you like? I would like 2. And I would also like 2 numbers in my password. And then I hit enter and it gives me the password that it has generated with 2 symbols, 2 numbers, and 12 letters. So that's a pretty strong looking password, if you ask me. Now I can use this and update my passwords to something very strong and very secure. So this is what we'll be building by the end of today. But in order to do it, we first need to learn some new skills and new concepts. So head over to the next lesson and let's get started. The first topic I want to talk about today is the concept of loops, things that have to happen over and over and over again. The first type of loop I want to introduce you to is something called the for loop. And it can be used really easily in combination with something we learned in yesterday's lessons, which is lists. By using a for loop like this, we can go through each item in a list and perform some action with each individual item. So let's try it out in practice. First, let's say we had a list called fruits and it contained 3 items: apple, peach, and pear. If we wanted to access each item in this list individually and print it out one by one, then we would use a for loop. So we start out with the keyword for, and then we give a name to a single item. So in this case, we might call it fruit. And then we use the in keyword, and finally the list that we want to loop through, which is our fruits here. Now we cap it off with a colon, and we go on to the next line and notice how it's indented there. Now I'm going to go ahead and print the value of each of the fruit variables. And if I run this code, you'll see that it loops through my list of fruits, and for each of the fruits inside the list, it prints it out into the console. apple, peach, pear in that order. Now, the important thing to realize here is that basically you can imagine that behind the scenes, what this code is doing is it's taking this list of fruits and it's assigning a variable name, fruit, to each of them. So the first time this runs, fruit is equal to apple. The second time this runs, fruit is equal to peach. And we can see this even more clearly if you run it through the Thonny IDE, which I told you about at the beginning of the course. Now, if I go ahead and click on the debug icon and I step into each of the steps, you can see first it establishes that we have a list of 3 strings, apple, peach, pear, and then we go into the for loop. Now, notice on the right here, I've got all the variables being accounted for. And the first one it's noticed is the variable fruits, which holds a list of strings. Now, as I continue into the for loop, notice how it's going to look through this list of fruits and it's going to assign the variable name fruit to each of the items, starting from the first one, apple. So now, by the time it's reached line 3, we've already got this variable called fruit that's been assigned to the value of apple. And so at this point, printing out the value of this fruit, it's obviously going to print out apple, as you'll see in the next step. There we go. Now, once I'm done here, then it's going to loop back to the start of the for loop, and now this variable fruit is going to be assigned to the next value inside the list of fruits. So now notice how the variable fruit is attached to the value peach, and then it continues this and so on and so forth until it prints out each one of the fruits. And this really emphasizes the most important aspect of loops. The loop allows us to execute the same line of code multiple times. In this case, we're executing the print statement 3 times, but our for loop isn't limited to just executing a single statement. We don't just have to print out the name of an item in the list. We can execute a whole block of statements multiple times. And we can do many things inside this for loop. And by inside, I mean indented. So let's say that in addition to printing out the fruit, I'm going to write another print statement. And I'm going to not only print out the name of the fruit, but I'm also going to say fruit plus space plus pie. So when I run this code, what do you think will happen?
It'll do each value in fruits, so print apple, then apple pie, peach, peach pie, pear, pear pie.
Well, it prints out apple, and then it prints out apple plus pie. And then it goes back to the start and it assigns the variable fruit to the next item, peach, peach pie, pear, pear pie. So this is how we can implement a simple for loop that loops through a list and assigns a variable name to each of the items in the list in order. And then inside the for loop, after the colon, after some indentation, we can do something with that temporary variable for each of the items. Now, I've been talking a lot about the concept of being inside a for loop versus being outside a for loop. And this is really, really important. Whenever you see a colon, say in our if statements that we saw previously or the for loop that we're using here, the indentation is really, really important because if it's indented, then it means that it's inside the for loop and these instructions will get carried out for as many times as the for loop will need to repeat. Now, if I decided that I wanted to, say, print my fruits, so my list of fruits up here, and I put it inside my for loop, so indented after the for loop, then as you can imagine, it's going to print that for as many times as the loop runs, which is going to be 3 because there's 3 items in our list. Now, if I had indented that back to the beginning, so now it's no longer inside the for loop, then it's only going to print once, and it's going to print it after the for loop is done. So notice how it's doing the whole apple, apple pie, etc. And then once the loop is finished, then it jumps to the next line and carries out this instruction. So the indentation is really, really important, and you have to be really careful with this. Have a play around with this code, and if you're still struggling to see how it works, then move the code over to Thonny and step through each step one at a time and see how it works. But I hope you're starting to see how loops are really handy at executing an instruction over and over and over again, getting the computer to save us time and energy. A really good example of when loops would come in really handy is, you know how Bart Simpson gets punished and has to write out a sentence over and over again on the blackboard? Well, if only Bart was a programmer, then he would be able to use loops to do this, and he would be able to chill in the corner. Now,
It's after
once
10
you're
o'clock
happy with
here,
this
and
type of for loop, then head over
this
to the
is
next lesson
delicious.
where I've got a coding exercise that's going to put your knowledge to the test. All right, so I'll see you there. Now, one of the things that you'll start to realize about the Python programming language, especially if you have experience of other programming languages, is that Python is extremely number friendly. It has a lot of built-in functions to help us work with numbers. For example, if I had a class of students and I list each of their exam scores inside this giant list, and I wanted to work out, well, what is the total exam score? So what if I added each of these numbers up together? What would I get? Well, Python has something called the sum, which allows us to put in any iterable data type, including lists. So I can put these student scores into here, and I can set this, let's say, to the total exam score. And then if I print this, you'll see that it has added up each of those numbers in the list, and it equals 2068. Now, if I wanted to do this manually, though, I could, because at the end of the day, all that's happened is the Python team, when they developed the programming language, they created each of these helpful functions. So we could create some ourselves as well, given that we understand how for loops work. So we could say for score in student scores, colon, and then in the indented block, we could say, well, we need to add each of these scores to each other, right? And then we need some sort of variable to keep hold of it. So let's create a variable called sum and set it to start off as equal to 0. And then we could say sum plus equals score. And every time this for loop runs, it's going to go to the next score and the next score. And each time that score is added to the previous value of sum. So then it accumulates in that variable. So now what we can do is go ahead and print the sum and go ahead and hit run, and you can see that it's exactly the same number as before. So this is a way that we can use the primitive parts of Python, so the building blocks of Python, to build out functionality for various use cases, such as summarizing each of the numbers in a list and adding them together. So here is your challenge. You're going to do the same, but in your case, you're going to try and replicate the max functionality. So this is a built-in function that allows us to pass in a list, for example, student scores, and if we print it, you can see it will pick out the largest number in this list, which happens to be 199. Now, your job is to replicate this functionality, but using what you have learned about for loops, about lists, about conditionals, and see if you can figure out how to achieve this. So pause the video now and give this challenge a go.
All right. I think we're already done with this page. Yep, highest score. All right. also a built-in Python called max and min, which allow you to pass in a list of numbers and it will give you the highest number or the lowest number. Figure out how the Python programmers might have built this functionality. Okay. Range. Okay. No idea what that range is there for. I don't think I missed anything. Either way, I think we can still do this. For score and student scores. Okay, so we're going to want a high score equals 0 just to kind of declare it. Alright, so we're going to check each score. If score is greater than high score equals score. Should be as simple as that, right? Print high score. And yeah, 199. Simple as that.
So similar to previously, we will use a for loop to loop through each of the scores in the list of student scores. And if you want to verify it as you go along while you're writing your code, it's always a good idea just to make sure that your code is doing what you expect it to do. So in this case, we're going through each of the scores. Now, instead of printing it, we want to check it against the number which we want to set as maximum. So similar to sum, we need a variable to hold all of the intermediate values until we reach the maximum. So let's create a variable called max score, and let's just set it to equal 0. Now, when we loop through each of the scores, we're going to compare the current score that the loop is going through. So the first time it will be looking at 150. And we're going to say, well, if the score that we're currently looking at, let's say 150, is greater than the max score, well, in that case, we're going to set the max score to this current score that we're looking at. And what this loop is going to do is it's going through each of these numbers. So let's go through the first 3 in order, just so that we can make this process a bit more clear in your mind. The first score is equal to 150. Is 150 greater than 0? Well, yes. So then this bit of code carries out, and now the max score is equal to 150. So for the next score, it's 142. So is 142 greater than 150? No, so we're not going to do anything at all. You could, of course, have an else statement that just prints something, but in this case, it's unnecessary. We only need to check for one thing, and that one thing is each time we loop through each of the scores, is it greater than the previous maximum? And now, if I go ahead and exit the indentation levels and go to the very start, so I'm outside of the for loop, and I print out the max score, you'll see that it will give me the same result as using the max function, which is 199. So if this code doesn't make any sense to you, I recommend going back to the previous lesson and revising what we learned about for loops. Alternatively, maybe you need to do some revision on how if statements and conditionals work. But either way, make sure that all of this code makes perfect sense to you and you can write it from scratch without having to look at the answer code. Because it's really, really important as we progress that I'm going to assume that all of this makes sense to you so that we can build upon our knowledge. And then once you're ready, I'll see you over in the next lesson. Now, up to this point, we've only been using for loops in association with lists. So we've been looping through the list and getting hold of each of the items in the list and then doing something with it, right? But we're not always going to be working with lists and using for loops. Sometimes we might want to use a loop completely independent of a list. And a good example of this is when Karl Gauss, the German mathematician, was just a child. When he was 10 years old, his math teacher gave him an exercise that she probably thought would tie him up for a little while.
Sorry.
And the idea was to get him to add all of the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4 plus 5, etc. all the way until 100. And even though she thought this would keep him busy for an hour or so, getting this young child to add up these numbers, and I can have some peace and quiet scrolling on Facebook, but unfortunately he came back to her within 2 minutes and gave her the answer. So how did he work it out? Well, he was actually a really smart kid, and he figured out that if you flip the numbers around, so 100 plus 99 plus 98, and you look at both of these two lines, you can see that 1 plus 100 equals 101, 2 plus 99 equals 101, 3 plus 98 equals 101. Basically, if you tie all of these numbers together, there's actually 50 pairs of 101. So he could simply just do 50 multiplied by 101, which is 5,050. And that's how he figured out the answer. But we can actually outshine Gauss because we can do this calculation in less than a minute just by writing a few lines of code. But in order to do this, we first have to learn about using for loops with the range function. Now, the range function is something that is really, really helpful if you want to generate a range of numbers to loop through. And the syntax looks something like this. So we've still got our for and our in keywords highlighted in blue. But instead of looping through a list, we define how our loop is going to work by creating a range. So in this case, I'm creating a range between A and B, and then I'm going to get hold of each number in that range and do something with that number. Now, it's important to remember that the range function doesn't actually do anything by itself. So if we create a range between 1 and 10 and we say just try to print this and we run, you can see it doesn't actually do anything. It doesn't print out the numbers 1 through to 10 at all. This function has to be used in conjunction with another function. And in our case, it's going to be with the for loop. So for example, if I wrote for number in range, and then my range is going to be 1, 10. So this is going to be the range that I'm going to create between 1 and 10, and then I want to get hold of each of the numbers inside that range. And this is going to be between 1 and 10, and not including 10. So if I go ahead and print out the number that I create from my for loop, then you'll see that what happens is it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, but not the last digit, which I've included here. So if I wanted all of the numbers from 1 to 10, I actually have to set a range between 1 and 11. And now when you run the code, you can see that it goes from 1 all the way up to 10. Now, by default, the range function will step through all the numbers from the start to the end, and it will increase by 1. Now, if you want it to increase by any other number, then you have to add another comma to the end of it and specify how large you want the step to be. So let's say we change the step size to 3. Now, if I rerun the same code, you'll see that it goes from 1, and then it steps by 3 to 4, and then it steps by 3, and then it steps by 3, finally to 10. Now let's come back to the problem that I mentioned at the beginning of this lesson. How can we add up all of the numbers from 1 to 100 by using code? So I want you to pause the video and see if you can solve the Gauss challenge. Have a go now.
Alright, this should be pretty easy. We just need sum equals 0 for number in range 1 to 101, because 100 will be included, but 101 will not. Sum plus equals number there we go.
All right, so how do we solve this? Well, it's going to involve the for loop, and it's going to involve the range function, because we're going to get hold of every number in the range between 1 and 100. So we need to write 101. Once we've got hold of all of these numbers, it's as simple as using a accumulator. So let's say total equals 0. And then inside the for loop, so that means indented, we're going to say total plus equals number. So now it's going to add every number in this range to the total starting from 0. And this is basically going to give us the sum of every number from 1 to 100. So let's go ahead and print it out and see if it matches Gauss's value. And there you have it, 5050. So now that we've beaten Gauss at his own game of math using programming, let's head over to the next lesson and try to complete a challenge using the range function to see if you manage to internalize and understand everything we talked about in this lesson. So for all of that and more, I'll see you there.
Alright, so this one, I hear it's, well, at least it used to be a common interview question, but I think the word got out about that, and now it's too easy and too common to be an interview question. So, alright. Just print each number from 1 to 100 in turn and include number 100. So we need range of 1 to 101. And the number is divisible by 3. Instead of printing the number, it should print fizz. Same for if it is divisible by 5, then it should be, then we should print buzz instead of the number. And if it is divisible by both 3 and 5, it should print fizz buzz. Alright, so for number in range 1 to 101, because 101 is the exclusive boundary. meaning it's not going to be included, basically. Okay. Alright, so I think it would be best to check for both divisibility by 3 and 5 first. But we don't want to actually divide. We want to do that modulo. So if number modulo 3 equals 0 and number print fizz buzz print fizz. And we're doing that because it'll check to make sure that both are not, and then it'll move on to check for each instance, because, you know, if it's not both, it could still be one or the other. And then, if it is not one or the other, oh, then it is a number. So that should be it. One, two, fizz. 4, buzz, fizz. 7, 8, fizz, buzz. 11, fizz. 13, 14, and we got our fizz buzz. 30 should also be fizz buzz. And there we have it. Noise.
Now that we've
Already at the
learned
final
all about
project.
loops in
Okay.
Python, we're finally ready to tackle our final project of the day, which is the PyPassword generator. Our program will ask us how many letters would you
been a
like
quick
in
day.
your password. So I will say I would like a long password, let's say 14. How many symbols?
Before
3.
this project,
How
at
many
least.
numbers? 4. And it's going to generate me a password that is almost completely impossible to crack by any hacker, no matter how talented they are. So the project of today is to build this password generator. Then you'll see that here I've already included for you a list of all the letters in the alphabet from A to Z, including the uppercase and lowercase letters. I've got a bunch of numbers and a bunch of symbols that are usually accepted by websites in the passwords. Now, there's 2 levels to this project. You can either go for the easy version, where all you have to do is generate your password in sequence. So for example, if the user wanted 4 letters, 2 symbols, and 2 numbers, then it might just look like this: 4 letters, and then 2 symbols, and then 2 numbers. So they're in sequence, right? First you've got the letters, then you've got the number of required symbols, and then you've got the required numbers. So this is the easy level. And then there is the hard level. And the hard level requires you to generate the password in a completely random order. So instead of having it being letter, symbol, number, it should be maybe letter and then a symbol and then a number, then a letter, then a symbol, and then a number. But notice how this is completely random. every single time you generate it, the order of where the symbols and where the numbers appear in your password are completely random. So, for example, if you look at the demo version and I do the same thing, 4 letters, 2 symbols, 2 numbers, where the numbers and where the symbols occur are completely unpredictable. So that's the hard level. I recommend trying the easy level first, and then once you've managed to do it, then take yourself up to the hard level if you think you're up to it. Pause the video now and try to complete the final project.
Alright, easy level seems like it'll be easy. The hard version, not so much, but I'm gonna try for both. Alright. Alright, so we have welcome. We get how many letters we want. We get how many symbols we want. And then we get how many numbers. Okay, so where do we start? So we have, or we will have the integer values of how many letters we want. Now we just need to get that many letter values for each letter in range 0 in our letters. And so we are going to need to import random. And just to make sure I'm on the right track, I'm going to just print a random dot choice letters. And we'll do the same thing for symbol, Smibble symbol. And I should have done numbers, but maybe it doesn't matter now. Alright, let's just see how that works. How many letters would you like? I would like 3, 2, and 2. Alright, well, it did print. But it's on a new line for each one, and we don't want that. guess we will create a empty generated password equals an empty string. Generate dot no. And you add does that work? Plus equals letter? I don't know, but we'll see. Actually, I'm still because we need random dot choice numbers. Same here. Symbols. I definitely spoke too soon about this being a short day. Okay, 3, 2, 2. Well, yeah, because I didn't have it print the actual generated password. That would be helpful. Hey, it works. Do it again just to be sure. 3, 2, 2. Very nice. And that was the easy one. Okay. I'm going to see if there is an easy way to do this hard version. So we are going to scramble string Python. I don't know what this join is. Well, let's just try something like that. But, I mean, word equals list. A word. I don't know. Let's try a different solution. So scramble, let's try shuffle. Alright. I think I'm starting to understand it a little bit more. I still don't understand what the heck this is. Or this part. Let's try this. Alright, we've already got our... I'm pretty sure that the string acts as a list, right? I don't know. We'll try it. Let's random dot shuffle generated password result equals whatever the heck that is. Join. And instead we will have result. No errors. 3, 2, 2, and there's our error. Okay. Does not support item assignment. So let's try shuffled password equals list. Let's try that. Looks good to me. Let's try a little more. 3 and 2. I don't entirely understand it. So if you don't either, you're not alone. But um, yeah, I mean, there mission successful. Let's see what she says.
Alright, so let's first tackle the easy level, where we're just generating a password with the required number of letters, and then the required number of symbols, and then the required number of numbers. So let's go ahead and tackle this one first. Now, we know that we've got these lists which we can draw from, and we know that we can use the random module to get hold of a random item from the list. So all we have to do is first get 4 random letters. So let's say that we had a password which just started out as an empty string. Then we can use a for loop to loop through all of the characters that we need to create for our password.
So what I'm understanding is that Python makes a very clear distinction between a string and a list. These letters, numbers, and symbols are lists, and they are very clearly not strings. Alright. Works for me.
For example, I might say for car, short for character, in the range of from 1 to the number of letters that the user wanted. So in this case, if the user wanted 4 letters, then it will be a range from 1 to 4, but not including 4. So it's actually from 1 to 3, which is only 3 characters. In order to modify this, we have to do what we did always before, which is just to add 1 to the end of our range. So now we're going to create a range based on the number of letters that the user wanted. And I'm just going to go along with the assumption that the number of letters equals 4. Let's just pretend that's what the user will enter. So then this range becomes 1 to 4 plus 1, which is 5. So the range is in fact going to be 1 to 4. For every single number in that range, from 1 to 2 to 3 to 4, I'm going to generate them a random letter, and I'm going to pick it out of this list of letters. To do that, I can either generate a random number and use it as the index, or you might have seen previously, I showed you the random.choice function. And inside this random.choice, we can pass a sequence, which in our case is the letters list. Then it will look through this list of letters and it will give us a random item from that list. So now that random letter is going to be something that we're going to need to add to our password, right? So we can set this equal to a random character. And now let's go ahead and just print it out. So let's say we want 4 letters in our password and we can type anything for the other ones. But notice how when the for loop runs, it's given us some random characters that it's picked out of our letters list. How can we add each of those letters to our password? Well, we can use the string concatenation that we learned very early on in day 1. We can say password equals the previous password plus the random character. Of course, the shortened version of this is just password plus equals random character. And now let's go ahead and instead of printing the random character, let's print the password at each stage of the loop. And again, I'm going to choose 4 letters. So you can see the first time the for loop runs, I get a capital H as the random character. And then the next time the loop runs, I get an A, and the A is tagged to the end of the H, so I get HA, and so on and so forth until I get these 4 characters in the beginning of what seems to be my random password that's going to be generated. Now, if you wanted to, you can actually simplify this down to just one step, because instead of having this intermediary, which is the random character variable, we can simply just replace it with the code, like this. So in this case, we're getting a random choice from our letters list. So we get a random letter, and then we add that to our password. Now that we've done that for the letter, then it's pretty easy to see how we can continue doing this for the symbol and the numbers. We just have to keep adding it to the end of our password. So let me quickly write out the code for this.
Instead of starting at 1 and then doing a +1 like she did, I just started at 0 and went up. So, I mean, it works.
So now, when the user requests that they want 4 letters in their password, then we generate a range from 1 to 5. And then for each of those positions, we generate a random letter in order to fill the password. And then we add on the required number of symbols and the required number of numbers. And finally, we print out the final password. Now, there's a way to simplify our code even more. Previously, we always used the range by starting from 1 and then going up to 1 over the number that we want. For example, when we wanted 1 to 100, we created a range of 1 to 101. Now, in this case, because all that we want is a range that covers all the letters, symbols, and numbers that the user wants. So if the user wanted 4 letters, then what we need the range to be is 1, 2, 3, and 4, which in this case is a range of 1, 5, because of the way that the range doesn't include the upper limit. Now, if we think about this logically, we can also change this to 0, 1, 2, 3. So then we can have a range of 0 to 4. So that means we can actually use the number of letters as the upper limit and then simply change this to 0 so that we don't have to add 1 to our number of letters. And I think this will make our code even simpler and hopefully simpler to understand as well. Now, if you prefer the previous version, which we've seen throughout the course, then feel free to keep it as it is. But this way, we get rid of all of these +1s, and you can see it's a lot tidier. Let's go ahead and run this code. And again, I'm going to choose 4 letters, 2 numbers, and 2 symbols. And I end up with my final password, which fits exactly that criteria, and it looks pretty random. But the only problem is that if a hacker knew that you always have 2 symbols at this position and 2 numbers at this position, then it's very easy to crack that password, because in order to get the last digit, for example, they only have to try 9 different variations: 1, 2, 3, 4, 5, 6, 7, 8, 9. And this just limits the strength of your password. In order to tackle that, you would have to tackle it at the hard level, which is, how do you get a password that has all of these letters and numbers in a completely random order? To do that, we mentioned that you have to do a bit of Googling because it might require something that you haven't done before. But in essence, you've got access to everything you need to perform the logic. So if you haven't given that a go, then this might be a good time to pause and have a think about how you might structure the logic, or how you might create a flowchart to express this logic that you would want. And once you've done that, and if you want to see the solution and walk through it with me, then come back here and I'll show you how to do it. But first, give it a go. All right, in order to tackle the hard level, what we essentially need to do is, instead of adding each of these letters into a string, we actually want to add it into a list. So I'm going to copy all of this that's here, and I'm just going to comment it out, and I'm going to paste it under my hard level and work on it here. So instead of using a password string, I'm going to create a list, and to better describe it, I'll change my variable name to password list. So now, instead of using password to add each of these letters and numbers and symbols, I'm going to be adding it to my list.
Right here, so.
Now, to add things to a list, you can use the same syntax that you did with strings, which is to add the new item into the list and to update the old list. You might be more familiar though with the syntax which is append. And both of these work. You can use either of them if you want, but they'll end up doing the same thing, which is to add each of those things you've generated in the order that you've generated to your password. So we end up now with a list with 4 letters, 2 symbols, and 2 numbers, all stored as strings because of the quotation marks around them. So now that we've got a list, well, then we have to think about, well, how can we shuffle our list? How can we mess up the order of the items in our list? And that might take you to Google, and you might search for something like how to change the order of items in a list. And then we also have to add our keyword, which is Python, because there's obviously a lot of other programming languages. And we come up against our first Stack Overflow question. How can I reorder a list? Well, that sounds kind of like what I want to do, right? So if we scroll down, you can see that the way to do it is either using a for loop like so, or to simply use the shuffle function. This is a much simpler way because it allows us to update the existing list just by calling the shuffle function.
That looks way easier than what I did. Oh, okay, because this output is still in list format, whereas we turn this list that is shuffled into a string and then join it with 0 spaces. So we're joining like each index of that list. Okay, that makes sense. So we're turning this shuffled password string into a list, or turning this generated password string into a list, and calling that variable shuffled password. Then we randomize that list, and then create a new variable that is a string, and join all of those list elements back together. Yeah, that makes sense to me. Okay.
Function on it. And this one actually requires us to create a new list, and we have to create a bunch of random numbers for the order and then to reorder them using a for loop. So I'm going to go with this version, and let's try it out. Let's print the password list before the shuffle, and then let's use the random.shuffle and pass in the password list, and then let's print the outcome of that shuffle. So let's print the password list again. So now you can see that we've got a version before and then we've got a version after. So if I run my code and I write again 4 letters, 2 symbols, 2 numbers, you can see that previously it was ordered in the order that we added each of the characters. After the shuffle, they're now pretty much random. There's letters in random places, there's symbols in random places. So if only we could turn this back into a string, then we've got our password that's nicely shuffled. So how can we turn it back into a string? Well, we could simply use a for loop, right? We could say for each character in the password list, we're going to add it to a variable called password, which is going to start off again as an empty string, and then we're going to add to it. So we're going to say password plus equals each character in our password list. And now if I go ahead and just print my final password, I'm going to add a f string as well. let's say your password is, then let's insert the password. And now if I run my code,
that's how I would have
and let's say
turned
I
the
want 12 letters,
list back into a
3
string if I
symbols, and
hadn't
4
come
numbers,
across that join
then
command.
it's going to generate me an entire password that's completely randomized in terms of the orders of the symbols and the numbers. And I've now solved the hard part of this challenge project. Did that make sense to you? Did you manage to get it to do what you wanted to do? If you're at all confused about the code that we've covered here, then be sure to check out the final project and take a look at how the easy level is implemented, how the hard level is implemented, and try switching it around so that you really get to understand it. Try, instead of maybe getting the user to tell you how many letters, how many symbols, how many numbers, instead just define those yourself or use a random number of letters, numbers, and symbols. Play around with the code until it starts doing what you want it to do and it starts making sense. But I hope you had fun building this project with me today and learning all about loops. On the next lesson, we're going to be learning more about these things that we've been using a lot, which is Python functions. So I'm going to bid you good night for today, and hopefully I'll see you bright and early tomorrow, and we'll learn some new skills and work on some new projects. So that's all from me. Good night from Angela.
She said that's all from her, and now there's still one more.
Hey, well done for completing day 5. Now I know that day 5 had a really difficult challenge at the end, so it must have taken some perseverance that you had to draw out of yourself in order to actually do it. Now, at this point in time, you might be feeling a lot of the same feelings that I had when I first started learning how to code, which is this overwhelming sense of like, maybe this is not for me because everything is so overwhelming and I don't understand it and it's just not clicking. Maybe I'm not meant for this. Maybe I was born to be a lobster, instead of a programmer. But you know what happened? I continued, I persevered, and at some point it actually all started clicking. It started making more sense. So just trust in the process, keep showing up and just put in those reps every day. And I promise that by the end of the course, you will not feel like this. You will feel like you're on top of this and you got it. This is going to happen. So keep going, keep doing what you're doing. You're doing a great job.
All right. Well, that's it for day 5. Still think it was a short day, but tomorrow we'll have some functions code blocks, which I thought today was supposed to be code blocks, but while loops also. So see you then.